finding the equation of a tangent, right, to the curve x squared plus 5x. So we know that that is a quadratic, and actually if we factorize it, we can see that it has an x-intercept at 0 and at -5. So before even trying the problem, try to sketch it in your head or on your calculator so we know it'll look something like that, right? And we're looking for the point 2, 14, so that's maybe about here, and we're looking for the equation of the tangent. So straight away we know that it's going to have a positive gradient and probably a negative y-intercept. Alright, so finding the equation of a tangent, we need two things. We need the gradient of the tangent, and then we need a point to find the y-intercept. Because we know any straight line can be defined by the gradient and its y-intercept. Cool. So just looking at the question, we are given a point, right? And that is the point actually where the tangent is tangent to the graph. So that's a very nice point to have. But we don't have the gradient. So to find the gradient of the tangent, we need the gradient of the function at the point the tangent is tangent to. So to do so, we need to find the gradient function, so dy by dx, so the gradient of the original function. So we need to differentiate. So x squared becomes 2 times x to the power of 1. So we multiplied the 2 out the front, and we subtracted 1 from the power, leaving us with 2x. The derivative of plus 5x is plus 5. But just like before, we take the power of 1, which is implied, multiply it out the front, we get 5. Subtracting 1 from the power gives x to the power of 0, which is equal to 1. So we are left with the gradient function as 2x plus 5. So to find the gradient of the tangent, gradient of tangent is the gradient of our function when x equals 2. Alright, because that's the point on the graph where the tangent intersects the function. So they will have the same gradient. So substituting in 2 for x, so we get the gradient, or m, is equal to 2 times 2 plus 5, which gives 9. Alright, so the gradient of our tangent is 9. Great, so we're halfway there. We have the gradient. Now our last step is to find the y-intercept. So using either y equals mx plus c, or you might have used point slope form, this one here, whatever you're comfortable with. We know the gradient, m, we know the x value, 2, and we also know the y value, 14. So either equation you use, you'll substitute in the known values, solve for c. So I'm going to use y equals mx plus c. So in for y goes 14, in for m goes 9, in for x goes 2. We're solving for c. So what's that? 18. Subtract 18 from both sides, we get c equals minus 4. Therefore, the equation of our tangent is y equals mx plus c, but m is 9 and c is minus 4. And then we're done. So just to recap this question, it was asking us to find the equation of a tangent, which is a very common question. Sometimes it's hidden in like another question, right? We were given the function and a point. So for the tangent line, we first needed the gradient function, and then we needed to find the gradient at the point given, right, the point of intersection 2, and doing that would be the achieved component, because you can differentiate and then you can find meaningful information from that. And then once we had the gradient, the last step was to put it into the equation of the tangent, right, by solving for C, and that's the merit component.